Hello science fans. Get ready to explore a chemical that's probably closer to your daily life than you think. Today we're diving into the fascinating world of acetone, a chemical you've almost certainly smelled at a nail salon or when using nail polish remover. But, did you know it's so much more than just a familiar scent? Acetone is a clear, colorless liquid that looks just like water at first glance. But, don't be fooled. It behaves in ways that set it apart from ordinary liquids. You'll find acetone almost everywhere. In cleaning supplies under your kitchen sink, in paint shops where it helps thin and clean, in auto body shops for prepping surfaces, and in chemistry labs for all sorts of experiments. It's not just for beauty. It's a true workhorse in many industries, quietly making tough jobs easier and more efficient. Acetone's real superpower is its ability to dissolve substances that water can't even touch. From sticky adhesives to stubborn paint, acetone breaks them down with ease, making it a go-to solution for tough cleaning tasks. When you use nail polish remover, acetone is the key ingredient that breaks apart the hard polymers in the polish, allowing you to wipe it away effortlessly. It's a little bit of chemistry magic at your fingertips. This powerful dissolving ability makes acetone essential in manufacturing plastics, preparing medicines, and even in the production of electronics. It's a vital ingredient in processes that shape the modern world. So, next time you catch that sharp, unmistakable scent, remember, acetone is more than just a smell. It's a behind-the-scenes hero, quietly supporting everything from your beauty routine to high-tech industries. Acetone bridges our daily routines with the world of science and industry, connecting what happens at home with the innovations happening in labs and factories. It may be a simple molecule, but its impact is huge, affecting everything from the products we use to the technology we rely on. So, let's take a closer look at how this remarkable chemical works, and discover why acetone truly is more than just a pretty smell. Let's get scientific. Today we're diving into the fascinating world of acetone, a chemical you've probably encountered more often than you realize. From nail polish remover to industrial cleaners, acetone is everywhere, but what makes it so special? Let's break down the science behind the super solvent. Acetone's formula is C3H6O, 3 carbons, 6 hydrogens, and 1 oxygen. This simple arrangement gives acetone its unique properties and makes it a standout among organic compounds. It's the simplest ketone, which means it has a carbonyl group bonded to 2 other carbon atoms. This structure makes acetone small, highly reactive, and able to interact with a wide range of substances. One key property is volatility. Acetone evaporates incredibly fast, even at room temperature. That's why you can smell it so easily, and why it leaves surfaces dry almost instantly after use. Its rapid evaporation also means it doesn't linger, making it ideal for quick cleaning jobs. But the real magic of acetone lies in its role as a solvent, a liquid that dissolves other substances. It can break down and carry away materials that water alone can't touch. Acetone is polar, like a tiny molecular magnet, so it can pull apart oils, fats, plastics, and glues. This polarity allows it to interact with both water-based and oil-based substances, making it incredibly versatile for cleaning and dissolving. It also mixes perfectly with water, which is unusual for organic solvents. This means it can be used in countless applications, from laboratories to household products, and can help clean up both water-soluble and oil-soluble messes. In industry, acetone is often called a universal solvent because it tackles everything from greasy machine parts to stubborn adhesives. It's trusted to remove tough residues that other cleaners can't handle. You'll find acetone as a key ingredient in paint thinners, degreasers, and glue removers. Its ability to dissolve and clean makes it a staple in workshops, factories, and even art studios. Its simple structure, strong polarity, and high volatility make it a chemist's go-to tool for preparing samples, cleaning glassware, and running experiments. Whether in high-tech labs or massive factories, acetone is everywhere, quietly powering processes behind the scenes and making modern chemistry possible. That's the science behind its superpowers. Acetone's unique combination of properties makes it one of the most important and widely used solvents in the world. Ready to see how it's made? Let's go on a journey to discover the fascinating process behind this everyday chemical. Where does all this acetone come from? Most is made in giant chemical plants using the camene process. It starts with benzene and propylene, hydrocarbons from crude oil. These react to form camene, with a catalyst speeding things up. Next, camene is oxidized with air to make camene hydroperoxide, an unstable intermediate. Finally, acid treatment splits it into two valuable chemicals, acetone and phenol. Phenol is used to make plastics and resins, so this process is doubly efficient. The cumene process is a brilliant example of modern chemical engineering. It's fast, efficient, and keeps up with global demand. That's how we get the acetone powering so many industries. Chemistry at its best. Before modern methods, acetone was made in a way that changed history. During World War I, Britain needed acetone for making smokeless gunpowder. The solution? A fermentation process using bacteria, discovered by chemist Chaim Weizmann. These microbes turned starches from things like corn and chestnuts into acetone, butanol, and ethanol. This ABE process let the Allies mass-produce acetone from simple crops. School children even collected chestnuts to feed the process. Weizmann's breakthrough helped win the war and later led him to become Israel's first president. Eventually, chemical methods took over, but this story shows how science and biology can change the world. Sometimes the tiniest things make the biggest difference. Did you know your body makes acetone too? When you run low on carbs, your body burns fat for energy, a process called ketosis. Your liver turns fat into ketone bodies, including acetone. Acetone isn't used for energy, so you breathe it out or pass it in urine. That's why people on ketogenic diets sometimes have fruity-smelling breath. It's acetone. For most, this is harmless, but in uncontrolled diabetes, high ketone levels can be dangerous and lead to diabetic ketoacidosis. So, a little acetone is normal, but too much is a warning sign. Your body is a tiny chemical factory. Acetone's resume is impressive. In beauty, it's the star of nail polish remover and some skin treatments. In industry, it cleans metal parts, preps surfaces, and is key in making plastics like plexiglass. Labs use it to clean glassware and prepare tissue samples for microscopes. The pharmaceutical industry relies on acetone as a solvent for making medicines. At home, it's in paint thinners, varnishes, and glue removers. Its ability to dissolve so many materials makes it indispensable. From salons to factories, acetone is a problem solver. It's everywhere, quietly making life easier. That's the power of a mighty molecule. Let's talk safety. Acetone is a powerful and versatile chemical, found in everything from nail polish remover to industrial cleaners. But while it's incredibly useful, safety always comes first when handling it. Acetone is highly flammable. Just a small spark or open flame can ignite its vapors. That's why it's essential to keep it far away from heat sources and always use it in well-ventilated areas, like near open windows or under a fume hood. Breathing in too much acetone can lead to headaches, dizziness, or even nausea. If it gets on your skin, it can dry you out or cause irritation, especially with repeated contact. That's why wearing gloves, goggles, and making sure there's good airflow are simple but effective ways to protect yourself. These precautions help you avoid both short-term discomfort and long-term health risks. When it comes to the environment, acetone is a volatile organic compound, or VOC. But unlike some other chemicals, it breaks down quickly in air, soil, and water, so it doesn't stick around for long or accumulate in nature. Acetone is less likely to contribute to smog than many other industrial solvents, and it doesn't build up in the food chain, making it a safer choice for both people and the planet. Still, it's important to use and dispose of acetone responsibly. Never pour it down the drain or toss it in the trash. Always follow local hazardous waste guidelines to keep our environment clean. Science is about making smart, safe choices every step of the way. Sharing knowledge and following best practices helps everyone stay protected. With just a little care and attention, we can harness acetone's cleaning power and versatility without putting ourselves or the environment at risk. Respect the chemistry, and it'll work wonders for you. Stay curious, stay safe, and always put safety first when working with chemicals like acetone.